Okay guys, today we're going to talk about ionic compounds. And ionic compounds are formed between a metal and a non-metal. So what happens is the metal always needs to lose electrons to become stable and form an ion, and the non-metal always gains electrons. So an ionic compound is formed when one element loses electrons and the other element, which is the nonmetal, gains those electrons. And the bond formed between the two elements is an ionic bond. So we are going to talk today about how to write the formulas for ionic compounds and how to name ionic compounds. So we'll start with how to write the formula for ionic compounds. So you're going to start off with a metal and a non-metal. So for example, if we were talking about lithium forming an ionic bond with oxygen. So lithium is a metal and oxygen is a non-metal. So automatically I know when lithium and oxygen come together, it is going to be an ionic compound because it's a metal plus a non-metal, okay? The first thing I'm going to do is I'm going to write the formula, or the symbol rather, for lithium with its ionic charge on the top. So the ionic charge of lithium is 1+. And remember, the ionic charge comes from the element wanting to have a full valence shell, so it will either gain or lose electrons depending on how many it has in its valence shell. We learned that a few days ago. So I'm going to start with lithium. I'm going to put the ionic charge on top. I'm going to do the same thing for oxygen. I'm going to write the symbol, and I'm going to include its ionic charge on top. Now, the ionic charge for oxygen is 2-. So I'm going to include that. Now, this is where we're going to incorporate what's called the crisscross method. Okay, so what you're going to do here, and I'll get another colored pen to show you, is you're going to crisscross the charges. So that 1+ is going to come down here to the opposite side alongside the oxygen, and this 2 is going to come down to the lithium. And so this formula is going to look something like this. Li, and the 2 now belongs to the lithium, so I'm going to write it as a subscript right underneath. Notice that it no longer has the negative symbol on it. You lose that. You're just writing the number. And then you're going to not put any spaces. You're going to write the second element, and you're going to crisscross that charge. So the one from the lithium is going to come down to the oxygen. Okay, so now I have something that says Li2O1. So let me clear this and write that again. Li2O1. Please notice that the metal always is written before the non-metal. This is non-negotiable. This is how you write it every single time. Now I'm going to change this to be Li2O. And just like in math, where no number represents 1, the same thing occurs in chemistry. So when there's only one atom of an element, you don't have to actually include the number. So Li2O is the formula for when lithium makes an ionic bond with oxygen. Now, to name it, it's quite simple. Let's make that a little bit neater, okay? Let's name this. So the naming rules are quite simple. The metal stays the same, so the name is going to become lithium. And the non-metal is going to have its ending changed to IDE. So instead of it being oxygen, it's going to become oxide. Okay, so the first element stays the same. The second element, the ending changes, okay, to IDE. And this is going to become second nature to you as we do more and more practice. Okay, let's try another one. So what would happen if magnesium was going to form an ionic bond with, let's say, chlorine? Okay, so the first thing you're going to do is you're going to write the ionic charges on top of both symbols. So magnesium has an ionic charge of 2, positive, and chlorine has a charge of 1, minus. The next thing you're going to do is crisscross the charges. So this 2 is going to come down to chlorine, and this 1 is going to go down to magnesium. And so this formula is going to become Mg1Cl2. Now, do I have to include the 1 on the magnesium? I don't. So the final formula is going to be MgCl2. So this is our final formula for when magnesium makes an ionic bond with chlorine. Now, if I were to name this, remember the first element, the metal, stays the same. So this is going to be named magnesium. And the non-metal changes its ending to IDE. So instead of being chlorine, it's going to be chloride. And all of these rules are in the PowerPoint that I have posted to the Google Classroom. So feel free to go back and forth between this video and the PowerPoint until you're familiar with the rules for naming. I'm going to do one more example with you where you're going to have to actually reduce the formula. So let's do one more, okay? Let's erase this. What about if magnesium and carbon were to join? So magnesium and carbon, okay? So again, the ionic charge of magnesium is 2+. The ionic charge of carbon is 4-. Now we're going to crisscross our charges. So this is going to become Mg4C2. And again, just like in math, we are going to reduce these numbers. It has to be the most simplified version. And I'm seeing that my subscripts are both 4 and 2. And I know that 2 goes into both numbers. So I'm going to reduce these by 2. So how many times does 2 go into 4? 2 times. How many times does 2 go into 2? 1 time. So really the finalized formula is Mg2C. And it's just C because I don't have to include the 1 because no number means it's 1. And the name would be the same. Magnesium stays the same, so it's going to be magnesium. And then the ending of carbon is going to change to IDE, so it's going to become magnesium carbide. Okay, so again, just to reiterate, an ionic bond is formed between a metal and a nonmetal. The metals always lose electrons, and the nonmetals always gain those electrons, and the bond formed between them is called ionic. When you are writing the formula, you're going to write the symbols for each. So you're going to, step 1 is going to be to write out symbols with the ionic charge on top. Okay. Step 2 is going to be to crisscross the charges. And then step 3, if you have to, simplify by reducing. Okay. So the more practice you do, the better you're going to get at this. And this is just one type of bond that we are going to learn about. So this is just the very beginning. So it's important that you master this before we move on to other types of bonds. Okay, so ionic charges, metal plus nonmetal, crisscross the charges, and remember the ending of the nonmetal, the ending of the second element always changes to IDE. It's important to note as we move on and things get a little bit more difficult, we can start organizing and remembering different rules based on hints that you can amass over what type of bond is what. And so what I mean by this is there's going to be clues that a bond or a formula is actually ionic. So when you're looking at a formula or when you're looking at a chemical name, ways to identify that it's ionic. The first thing is it a metal and a nonmetal? If it is a metal bonded with a nonmetal, that means it's an ionic bond. So is it a metal plus a nonmetal? So that's a good indication that you have an ionic bond on your hands. The other way is when you're looking at the name, does the nonmetal have IDE as its ending? Okay, so when you see a metal plus a nonmetal and the nonmetal has IDE as the ending, that's another good clue that it's an ionic bond. Okay, so these are ways that we can start recognizing the type of bond that something is. Okay, so keep that in mind as we move forward.